Find the work done by the force field F of xy is equal to x squared I plus y e to the xj on a particle that moves along a parabola x equals y squared plus 1 from the point 1, 0 to the point 2, 1. Here we see that our vector field F is in 2 dimensions, and when we saw the introduction to vector fields, everything was in 3 dimensions. Everything still applies the way you would expect in 2 dimensions. Our curve is the parabola x equals y squared plus 1. And what we need is a parameterization of this curve. If it was a circle, we would use our polar conversions. They give us a nice circle. But here, since we have x is really a function of y, that tells me that I can use y equals t as the parameter. Or more informally, we could actually say y equals y. In order to keep with the notation that we've been using, though, I'm going to stick with y equals t. If y equals t, then x, of course, is equal to t squared plus 1. And now we need bounds on t. For those bounds, we can consider we're going from the point 1, 0 to the point 2, 1. And that tells me that y is going to go from 0 to 1. And for us, that means that t is going to go from 0 to 1. So the curve C is given by r of t, which is equal to t squared plus 1 t, as t goes from 0 to 1. And then we are going to express the vector field F in terms of r of t. And so we have t squared plus 1, the quantity squared, comma te to the t squared plus 1. Knowing what r is gives us r prime, and so r prime of t is equal to 2t comma 1. Now I'd like for you to go ahead and set up and evaluate the integral of f dot dr with the information that we have here. All right, let's see what we have. The dot product gives us t squared plus 1, the quantity squared, times 2t, and plus te to the t squared plus 1 times 1. Now you see that written kind of a lot here. What I'm noting here is that for t squared plus 1, the quantity squared, if I consider u to be t squared plus 1, du is 2t dt, and I have a factor of du right next to this, so I'm actually just going to use the power rule there. Likewise, in the second term here, if the exponent is t squared plus 1, I'm going to call that u, so du is again 2t dt. This time I need to multiply and divide by 2 so that I have my du. Integrating the first term is going to require the power rule, and so 1/3 times the quantity of t squared plus 1 cubed. The second term is simply 1/2 e to the t squared plus 1, retaining the denominator factor of 2 because the numerator factor of 2 was used up in the du. Evaluating these expressions at 1 gives us 8/3 plus 1/2 e squared. Evaluating at 0 gives 1/3 plus 1/2 e, when we subtract those because of the fundamental theorem of calculus part 2, and we end up with a final answer of 7/3 plus 1/2 e squared minus 1/2 e.